Alright guys, this one's gonna be a big brain moment. So stick with me. We're talking about the J-36. You might think you know all about this mysterious Chinese stealth fighter concept, but there's so much more to talk about and new information that we need to cover. That's why we put together this series to break down every facet of this plane. In this episode, we'll be discussing some of the most fascinating aspects of the J-36 and sharing insights that go beyond what's available in public discourse. If you want to join us, then buckle up because we've got a lot to cover today. Let's jump right into it. Okay, first things first, the J-36 probably isn't going to look exactly like that. The visuals you're seeing here are probably just illustrations based on how the Chinese are designing their stealth jets. But let's take a step back and look at why the J-36 is such a big deal. Think of it like this. The J-20 is like the Chinese version of the F-22 Raptor. It's a 5th generation fighter that's great at air-to-air combat and has decent air-to-ground capabilities. Meanwhile, the J-36 is being touted as China's secret weapon to rival the US's 6th generation Next Generation Air Dominance Program, or NGAD for short. The NGAD program is developing a new family of fighter systems, including a 6th generation fighter that's supposed to maintain American dominance in the skies. The NGAD fighter is designed to have stealth capabilities, supercruise without afterburners, advanced sensor systems, and the ability to carry both air-to-air and air-to-ground munitions. Now here's where the J-36 comes in. Chinese media outlets have been teasing this project for years, and we're just now starting to get details about it. All we know so far is that the J-36 will have a tailless delta wing body configuration, which means it won't have any vertical tail surfaces like the ones on the J-20. Instead, it will rely on other forces like thrust vectoring to generate lift and control its movement. One of the main challenges of developing a 6th generation fighter is figuring out how to make it stealthy. Stealth is important because it allows the aircraft to avoid detection by enemy radar systems, which makes it harder for them to be shot down. The Chengdu J-36 reportedly uses a combination of traditional stealth features, such as radar-absorbing materials and serrated edges to reduce its radar cross-section, or RCS. However, it also incorporates newer technologies such as plasma cloaking and laser-induced absorption. Plasma cloaking works by creating a thin layer of ionized gas around the aircraft that absorbs and scatters radar waves, making the aircraft harder to detect. Laser-induced absorption, on the other hand, uses lasers to heat the air molecules around the aircraft, creating a haze that obscures the aircraft's outlines. This type of technology is still in the research and development phase, but it could potentially make the aircraft even more difficult to detect than traditional stealth aircraft. What's more, the aircraft will also have a highly classified integrated AI co-pilot system that will help the pilot control the aircraft and make decisions in the heat of battle. AI is becoming increasingly important in modern warfare because it can process information faster and more accurately than humans. Having an AI co-pilot could give the J-36 an edge in combat, because it can help the pilot focus on the bigger picture instead of getting bogged down by the details. The co-pilot can handle tasks such as managing the aircraft systems, engaging targets, and coordinating with other aircraft, freeing up the pilot to focus on flying the aircraft and making high-level decisions. However, it's worth mentioning that AI also has its limitations. It can only function as well as the data it's trained on and can't adapt to new situations or threats without human intervention. Therefore, the J-36's AI co-pilot will likely be designed to work in tandem with the pilot, leveraging the strengths of both man and machine to maximize effectiveness. But the J-36 is not just about stealth and AI, it also has some pretty impressive engine specifications. The engines are rumored to be capable of thrust vectoring, which means they can change direction independently of each other, giving the aircraft greater maneuverability. Thrust vectoring is commonly associated with maneuverable fighter aircraft, particularly those that perform aerial acrobatics or dogfights. By controlling the direction of the thrust produced by the engines, these aircraft can perform sharp turns, climb steeply, or even fly backwards. This capability allows them to evade enemy fire, pursue targets, or simply display incredible aerial agility. In addition to thrust vectoring, the engines are also expected to be capable of supercruise, which means they can fly at supersonic speeds without the need for afterburners. Afterburners are essentially rocket engines that burn fuel and provide a burst of thrust, but they're not very fuel efficient. Being able to supercruise would give the J-36 a significant advantage in terms of range and endurance, making it a formidable long-range fighter. To achieve this, the J-36 will likely use adaptive cycle engines, which are a relatively new type of jet engine that can switch between different operating modes to optimize performance. For example, the engine can switch to a higher bypass ratio mode for efficient cruising and a lower bypass ratio mode for maximum power during takeoff or combat. These engines are still in development, but they hold great promise for future fighter aircraft. So with all these advanced features, you're probably wondering how the J-36 will fare against the NGAD. Well, the truth is, we do not know because the NGAD is still in development and many details about it are classified. However, we do know that the NGAD is designed to have stealth, supercruise and advanced sensor systems similar to the J-36. Therefore, it's safe to say that these two fighters will likely be evenly matched in terms of raw performance. However, the J-36 may have an advantage in terms of cost. China is known for producing military equipment that is significantly cheaper than their Western counterparts. For example, the J-20 is estimated to cost around $75 million, while the F-22 Raptor costs over $350 million. Therefore, it's possible that China could produce the J-36 for less than half the price of the NGAD, giving it a significant advantage in terms of affordability. Now, before we move on to the next section, I want to give a shout out to our supporters. Your support helps us keep this channel running and we really appreciate it. If you'd like to show your support, you can check out the link in the description below. As we dive deeper into the technical details of the J-36, we'll also touch upon some of the advantages and disadvantages of its design choices. One of the most noticeable aspects of the J-36 is its tailless delta wing design. Proponents argue that this design results in a lower radar cross-section or FCAS, making it harder for enemy radar systems to detect. Additionally, the lack of tail surfaces reduces weight and drag, allowing for increased speed and maneuverability. However, critics argue that tailless aircraft are generally less stable and require more sophisticated control systems. They also tend to have a shorter lifespan due to the higher stress on the wings and fuselage. The J-36 is rumored to be made from advanced radar-absorbing materials that can absorb and dampen radar waves, reducing its FCAS even further. These materials are typically composites or polymers with a high dielectric constant and low loss tangent, which helps them absorb electromagnetic energy without degrading quickly. However, these materials are also expensive and require specialized manufacturing techniques, which could increase the cost and complexity of the J-36. Another intriguing aspect of the J-36 is its use of thrust vectoring engines. Proponents argue that thrust vectoring provides greater maneuverability and controllability, allowing the aircraft to perform tighter turns, climb more steeply and even fly backwards if necessary. Additionally, thrust vectoring can improve the aircraft's dogfighting capabilities, making it more effective in close-quarters combat. However, critics argue that thrust vectoring is mechanically complex and adds weight to the aircraft, which could compromise its range and payload capacity. Furthermore, thrust vectoring systems can be susceptible to mechanical failures, which could lead to a loss of control. The J-36 is rumored to use advanced electronic warfare pods integrated into the fuselage to jam, deceive and disrupt enemy radar systems, communications and sensors. These pods typically contain electronic warfare suites, including transmitters, receivers, antennas and processing units that can generate and transmit high-powered radio frequency or RF energy to interfere with enemy systems. However, electronic warfare is a highly dynamic and evolving field and enemy systems are constantly adapting to counter electronic warfare measures. This requires the J-36 to have advanced electronic warfare capabilities and robust countermeasures to ensure its effectiveness. Overall, the J-36 is an exciting development in the world of aviation and military technology. While some aspects of its design may face challenges, its innovative approach to stealth, AI integration and advanced materials could revolutionize future air combat. As China continues to invest in cutting-edge technologies, the J-36 has the potential to become a formidable force in the global arms race. And that's it for today's episode. Thank you for watching and be sure to stay tuned for more videos like this. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe so you never miss an upload. Until next time, stay curious and keep learning.